In today's class, we'll cover design of horizontal alignment. Basically, this chapter we'll be completing in six video lectures. There are different component or elements of the horizontal alignment, and they are design speed, horizontal curve, super elevation, type and length of the transition curve, and extra widening provided in the pavement surface, and setback distance. So these are different elements which we need to cover in this particular classes. Okay, so basically design speed is the main factor on which geometric design elements depends on. So basically this is the main factor on on depending on which different horizontal alignment component are designed. Okay, that's why this is called design speed. Now design speed of roads depends upon class of the road and terrain. So as per IRC, that is Indian Road Congress, there are four terrain classification, that is plain, rolling, mountainous and steep, and cross slope of the country in percentage, and these are the cross slope based on which this terrain classification has been conducted or done. Okay, so if the slope is 0 to 10%, in that case it is plain terrain. If it is slope is 10 to 25%, in that case it is rolling terrain. If the slope is 25 to 60%, in that case it is mountainous terrain, and if it is greater than 60%, in this case it is steep terrain. Now design speed is varying according with the different terrain. Okay, and based on the different road classification. So for example, national highways and state highways, for plain terrain, that ruling, that is the average is 100 km per hour, and minimum is 80 km per hour. So basically this division or these design speeds are provided for all the types of terrains and for all the different types of road as per the classifications. Okay, so our next topic is horizontal curve. So basically a horizontal curve is a curve in a plane to provide change in direction to the central line of the road. So when a vehicle traverses a horizontal curve, the centrifugal force acts horizontally outwards through the center of gravity of the vehicle. Now the centrifugal force developed depends on the radius of the horizontal curves and the speed of the vehicle negotiating the curve. Now this centrifugal force is counteracted by the transverse frictional resistance developed between the tires and the pavement, which enables the vehicle to change the direction along the curve and to maintain the stability of the vehicle. Now if the centrifugal force is P, then P is given by P equal to W into V square divided by GR, where P is the centrifugal force in kg, W is the weight of the vehicle in kg, R is the radius of the circular curve, V is the speed of the vehicle in meter per second, and G is the acceleration due to gravity, which in this case is 9.8 meter per second square. Okay, now this centrifugal force is, as per the equation, is P equal to WV square divided by GR. Now this ratio P by W, so if P by W, it is V square by GR. So it is known as the centrifugal ratio or the impact factor. Okay, now this centrifugal ratio is thus equal to V square by GR. Now the centrifugal force acting on a vehicle negotiating a horizontal curve has two effects. Okay, first one is tendency to overturn the vehicle outwards about the outer wheels, and tendency to skid the vehicle laterally outwards. So first one is called, that is the tendency to overturn the vehicle, it is called overturning effect. And the second one, that is tendency to skid the vehicle laterally outwards, it is called transverse skidding effect.